Hi, so RGB LED Programmer for the Arduino. I've got the window open. The first thing I'm going to put in this program are some comments at the very beginning. I'll paste those in to save time. Same as any Arduino program. We have two methods, the setup, which is only going to run the program starts, and the program loop, which will run round and round all the time the program is playing. Before we do any of this, we need to set up some variables and constants. So again, I'll paste these in. First one is LED. This defines the pin numbers that are denoted for the red, green and blue LEDs. These can be analog pins, but you need to check which pins give a PWM output on your model of Arduino. Second constant is set to the number of LEDs, which is 3, and the delay, which defines how large each program loop goes for, is currently set to 2.5 seconds, though we can experiment with that later. These values are all used by the analog fader section. They set the initial brightness on each channel, the fade amount, the adjustment level. I have documented in the article on the blog. It's an attempt to get a purer white than you get by just driving the RGB and LEDs at 100%. This is a problem with many LED strips. And the max level, although the Arduino can count up to 256, I've elected to just use 16 steps. So including 0, we've set these to 15, 15 and 15. I also have to square it to get it more linear, and 15 squared is 256. This will get a much more linear effect to the eye than if we just did it straightforward. First thing we're going to put in the program loop is the digital sequence, where we just turn each LED on and off 100% in a sequence. Each section shows you which colour it's going to produce by turning on which LEDs. So obviously if only the red LED is turned on, you're going to get red. And then we move on to the yellow. To generate yellow, we turn on the red one and the green one, etc, etc. Green has just the green, cyan has green and blue. We have to explicitly turn each one off as well. So just to get blue, we need to turn red and green off and just have blue. Purple will be red and blue together, and a white effect is created by turning all 3 on together. As it's a digital effect, these are turned on and off completely. The next part we'll put in is the analog loop. This will cause the LEDs to fade in sequence. In the analog fader, it'll vary the brightness of each LED to get a pleasing smooth fading effect. And it will be set to the number of LEDs. Anything between do and the closing bracket will be run conditionally until n is equal to that number. So it's 0 the first time. At the bottom of the loop we increment the value of n until it's equal to the number of LEDs. When it gets to 3, the loop will cease and then it'll go back to the main program loop. Then n will be set back to 0 again the next time. So it literally calculates the value each LED needs to be to in sequence. Values are stored in arrays, so instead of having single values, they have pigeon poles with 3 values, one for each LED. First thing we do is write the current values to the LED, set the brightness level to the starting brightness level. So it'll be for the first time. Ignore the adjust level for now, we'll come back to that. And then the brightness will be changed, either incremented or decremented by the fade amount. If it's positive it increases, if it's negative fade amount it will decrease. So the fade amounts of value you can play with, it'll increase or decrease the amount of steps in the sequence, but I wanted it as smooth as possible. So 16 was the minimum number of steps I decided would give a smooth effect. None of these values necessarily start off at 0. They start off at preset points so that they're all 120 degrees out of phase. So they start off at 4, 7 and 0. The 4 will be reduced initially, the 7 will be increased and the 1 will be increased. When they hit their maximum values, they will then reverse and come back down again. So the adjustment level is a preset value I've arbitrarily decided. This is an attempt to produce a purer colour of white. As the loop goes round, it's going to check each value against the fade amount, and it'll either increase it or it'll decrease it. So no value can ever go less than 0 or more than 15. Pretty standard practice in if conditions. So the bottom part of it will then decrease it each time until it gets down to 0. The top one will increase it each time. And the value of n will send it round to the next LED each time. So it executes 3 times. There's a delay for 2.5 seconds or whatever you set it to, and then it goes back into the main loop, which will go round indefinitely until we tell it to do otherwise. What we need to do now is we need to tell the main program loop which programs, which methods to run and when to run them. So at the moment, analog fader is in and digital fader is commented out. It's possible to add extra lines of code for debugging depending on what your software development environment is. We can then upload it to the Arduino, and you'll see some information about the chip coming back from it, and it's showing the communication process. It tells you the size of the programs, what voltages it's running at, etc. And then at the bottom it'll say AVR dude OK, and you know it's completed successfully. If there was a mistake or a syntax error in the program, you would get an error at the bottom. And I'll just demonstrate that by setting a variable that's illegal. And you can't set an integer to a string, that breaks it. Okay, so here's the assembled product. I've made a little PCB for it. I've assembled all the components onto some prototyping board or Vero board. This is just permanently mounted to my Arduino testbed and connected directly to the RGB light, and I've added 2 buttons. The first one, when you turn it on, will be the digital sequence, so that's going to go red and green together, then green on its own, then green and blue together, then blue on its own, and then white-ish. So if I click to the next program, this is now the analog version, so the transitions will be more gradual. What we can do now is use the other button to speed it up. Each time I will press it, it will halve the time delay from 2.5 seconds, 1.25 seconds. I'll press it a couple of times so you can see the event. That's 1/3 of a second between steps. You get a really smooth transition now. It gives a very pleasing effect. And then we can go back to the other sequence. We can see that that's switching digitally now. Sometimes it'll jump because of my fingers touching the wires. That's green on its own, that's blue on its own. And then it goes back into the sequence. So I've added extra steps that just produce RG and B. There's the red on its own, green on its own, and then it jumps back into the digital sequence. That's the very fastest setting, and if I press it once more, it goes back 5 seconds. It's personal choice, but I like it on 2.5 seconds. You can get some very pleasing effects with this by playing around with the variables. It's a proof of concept as much as anything. The idea is for you to experiment with the code, design your own lighting products to put the LEDs in. I'm going to assemble this on the back of my television so that it gives a nice ambient light. And you can also cut the strips and resolder them into different patterns and different layouts. It's about every 3 LEDs. You cut through it with a pair of scissors. I'm going to make 4 lengths to go around the television. And then I will have to resolder them all together with flexible wires in between. That will project onto the back wall, and that will light up this side of the room and make a very pleasing effect when watching television. Very similar to an ambient light product that is around, and it's actually just been re-released. That's the RGB LED project. You can do many different things with it. It's limited only by your imagination. You could also fit it into a case. You could use an Arduino Uno or Nano to make it smaller. It was such a job to get the components to sit on there. It doesn't really matter about the size. And you could use FETs for cleaner switching. So I'll just remove the board to show you what's underneath. There's an odd pin with an orange wire on it because the spacing of the connectors on the Uno is not equal. There's 3 tip 41C power transistors. Those are the resistors to pull down the switches. And then 3 100 ohm resistors feeding the bases of the transistors. All the emitters are connected together with the black wires, and the red, green and blue wires are the feeds from the collectors to actually drive the LEDs. The thick red wire is the 12 volts coming in from the power supply. The black wire is the ground. You have to connect the ground both to the 12 volts and to the USB on the board, otherwise you'll have serious problems. That connects to the emitter on all the transistors equally. If you don't do that, there's a danger that it'll pass a large voltage back into the Arduino and destroy it. The orange wire has now fell off because it's made of miserable thin wire, and that's easily resoldered back onto the board. I'll improve this circuit as time passes. Thanks very much for watching, and I hope it's been useful to you.